Okay, yeah. So the idea behind this workshop was, there's some, at this point we have some old phones lying around and I didn't really know what to do with them. So I wanted to, they have nice sensors. Uh, you got the camera, you got GPS, you got, accelerometer, and those are all things that are pretty useful for if you want to make a robot. And instead of buying those sensors separately, it would be nice to just like use what you already have. Um, so I was looking for ways to do that, and the easiest way to find these interfaces on the phone is actually through the web technology. So JavaScript, you can access the camera, the GPS, and this accelerometer pretty easily. But then the question is, how do you transfer that information to the robot? So that's where ROS comes in. And I guess I'll start sharing the screen. Okay. Okay, I guess I'm seeing, okay. Right, so I have this repo here. I'll post this in the chat. This is sort of a collection of scripts I made to sort of quick start the process of installing ROS and then running those Python servers, which you'll then be able to log in with your phone or any device really, and either publish all this sensor information, as well as I have a little control panel, which I'll show later, to control a robot if you have one built. And I'll actually demo that at the end. Right, so yeah, just I guess to explain what ROS is at its core, it's a message passing system. So there's a lot of robots out there, and it would be annoying if you had to like specially program your algorithms or sending sensor information from generic sensors to all these robots. So people created this thing called ROS. And it's like sort of the middleman between the driver of the robot and whatever API you want to use. So you basically it has a lot of language connections, Python, JavaScript. In this case, we'll be looking at JavaScript for the sensors. So yeah, I mean, I guess just to briefly explain how the installation works, I encourage you to look at the full tutorial in this link, but I sort of made it a bit easy by just offering like a script that if you're on Ubuntu, it'll just work. Yeah, caveat about ROS is that it tends to be tied down to an Ubuntu version. I do believe there's a version available for Windows, but I have not really worked with that myself.
But there's ways to get around that with virtual machines.
Yeah, I recommend when in doubt, just use a virtual machine. uh, cool. And in addition to installing ROS, you also need something called the Roslibj suite. So it's just a package that basically launches this WebSocket. And then in this environment, I also included another script. So that's the create workspace. So this actually does a few things that basically it lays out the directory structure that ROS needs, which is basically just a source folder, and then the source folder you can have packages that you compile. So it clones that. So I can maybe show this. So this is, I've already run all the commands and it populated things. So as you can see in the source folder, we need two apps for the things I'll be showing you today, and that's an async web server and a web video server. And this basically just allows us to publish video. I believe you don't even need these things if you only care about controlling. But yeah, if you want to get the sensors, which is sort of the interesting part of this idea, you need these packages. Um, cool. So then how do we actually use things? So once once you've ran the workspace, once you've installed everything and ran the workspace in this directory, you run catkin make and it compiles it for you. It usually takes a bit longer, but it doesn't compile things twice, so it ran pretty quickly right there. Okay, what's the first thing to explain?
Catkin is a part of the ROS installation?
Yes, yeah. Oh, good. Okay, good question. Yeah, so Catkin is sort of like the build. What's that called? Yeah. So, are you familiar with CMake? Is everybody familiar with CMake? So Catkin is like a build manager for ROS. It sort of handles the compilation. So if, for example, if I go to one of these packages, they have like an XML file basically describing their dependencies. So it maintains, it keeps track of like which packages are dependent on what, and it knows what to link together when compiling. Yeah, and it's part of the ROS installation. It's not a separate thing. Right. So then, in order to, I guess, just maybe explain a little bit about ROS, ROS basically runs a server. So if I type in ROS core, once ROS is installed, it basically it already starts serving, and then there's so what does it serve? It serves sort of this entry point, which is called the topic, and there's a command ROS topic list. So you can see, I'm not actually, this is the bare bones. It's not really doing anything except giving some meta information. Once I launch sort of a service that was built under ROS, we'll see more things populate. So for instance, how do you launch a service? So you can do ROS run to run a very specific thing. For example, I think if I wanted to view an image, there's multiple sort of programs that are built in for viewing images. I'll show that a bit later. I feel, am I skipping something? Yeah, if anybody has questions, feel free. Typically, the way you launch services is actually through launch files. So I've created a launch file, and the format of it you can sort of read up online, but I'll just give a basic idea. Is you can specify arguments that you want to take, as well as default parameters. You can include other launch files and send to them arguments, and then every service that you want to launch is basically a node. So in this launch file, I'll be instantiating this web video server, as well as another thing called republish. This is this republish service will just rename one of the topics. Basically, it's a sort of a convenience thing. So yeah, maybe we'll just run it. So to launch, you do ROS launch, specify the launch file. Well, what's it complaining about? Where videos? So, oh, maybe because I didn't. Yeah, I did skip a step. When you're running for the first time in a terminal from after logging in, you have to source a file after compiling. So yeah, don't ever forget to run that, or it won't be able to
Do you know what's
launch.
in that file?
It it basically sets a bunch of environment variables that so that it knows where things are. So for example, like after you compiled things, it created this build directory, right, where it built the all the files, and you got maybe some script files and subfolders, and in order for it to know where all those files are, you need to source that. devil setup file. I do believe I have that on. Yeah, I do actually mention that here. Okay, good. But I forgot myself. That's why I wrote it down. Okay. So I launched a application. Now, what does this application do? This is just a WebSocket. Let's give it something to actually do. So I guess maybe I'll show the demo and then maybe explain how some of those things work. And typically, so right now whoops. So the robot has its own thing, but I forgot to turn it on, which is why this is failing. So I'll restart that in a second. In the meantime, I'm going to start the web servers. Okay. Yeah, the other thing that gets annoying is you tend to have a lot of terminals open for all the things that you need to start. Okay, is it gonna connect? Okay, good. Okay, so what's the deal here? Yes, because I'm already running this. Okay, good. Okay, so just to summarize, I ran one launch file which started the robot drivers and how to control it. I started another one which started this WebSocket. And then I also just ran a Python web server. So now let's see what that looks like. So this is sort of the web page, which I'll explain how I created later. That if I put all up on my phone, I'll be able to use the accelerometer and GPS. But right now I can here I can just use. I have to refresh. I can use the camera. Okay. Apparently I can't use the camera. Let me see if it works on my phone. So just to show everybody, I opened it up on my phone. I click the camera. And now how do I debug that it's working? I can run the image view service. And the way you pass parameters in command line is this weird colon equals. So I'm telling it to point to camera image. How do I know that camera image is a thing? I go to ROS topic list. I see that there's a thing called camera image. Okay, good. It's working. So I was able to, from my phone, stream the camera footage to ROS, and now it'll be able to, I can use it, if I had some algorithms that I want to do with, camera, or I'll show you some teleoperation setup in a few minutes. Let me close this. Okay. Let's take a look at what about the accelerometer. So on my phone, I click the button for the accelerometer. And now I can take a look. So I'll show you the code later, but basically I published something called the topic gyro. And if I want to debug what it shows, I can echo it. So I ROS topic echo / gyro. And I can actually see as I move my phone, the orientation is changing. It's angular velocity is changing, linear acceleration. Great. So it's actually pretty good latency too. I'm surprised. Yeah, that was something I was actually really concerned about, like how bad would latency be if I'm just using like some web technology instead of hardwired. But it I guess it depends on your connection ultimately. And actually, so what are one of the benefits to uh, using the web as well is that anybody can go to this link right now, right? So I'm gonna post this, and if somebody wants to click on that link and try it out for themselves, uh, share the camera or your, well, I mean, I understand if you don't want to, nobody's, or filming right now, but
Does anyone want to try it out? No? Cool.
okay,
Okay.
yeah,
I'll
whatever.
do
Nobody wants to
it.
try. Oh, you okay? Good. Yeah.
Yeah. Okay. So my Mac is going to give me a problem because it's telling me that the connection is not private. So I just have
Oh,
to.
yep. That's because it's not right. I forgot. You need to first connect to this link. Okay.
Okay.
Okay. So somebody asked the question. For this, we need a VM or Ubuntu. That is correct.
Yeah.
Yeah.
Just
Uh,
because ROS isn't really supported on any other operating system, and
right.
not
So
because like anything else that we're doing is specifically tied to Ubuntu.
yeah, I mean, well, I mean, the script I have is written for Ubuntu. You could install ROS on other things. So these are like the three sort of maintained ones at the moment. If I look at the latest one, okay, Windows is considered an experimental distribution, so take that as you will. Um, I'm sure, I haven't actually ever tried it myself, to be honest, but they seem to have a way of installing it if you're willing to follow that tutorial. Um, I think it's a lot easier to just use a VM. What are the differences between ROS distros? Uh, Interesting question. Yeah, they basically just update the things. API can occasionally change. It's actually quite annoying, but but yeah, every time there's like sort of a change in the API that's major, they'll have a new version, and that new version is pretty much always recommended, and I treat recommended as locked to that version of Ubuntu.
Yeah.
Um, Technically, you could install it on any Linux system as long as you compiled it yourself. The problem is ROS has so many dependencies that it's basically unreasonable to do it on anything except the recommended distribution. So somebody's saying this is not a sort of compiler, but we need a different OS to. Well, I mean, right. If you're not currently running Ubuntu, then yes, you technically need a different OS. Um, the other thing is usually when it comes to ROS, like you'll have, like if you're working in like the industry or in a lab, like you're gonna have a dedicated computer that is hosting like the robot code. Um,
I guess the best analogy for this is that ROS is kind of like Python in that it's like a tool that you can use on a computer, except the people who made Python built it so that it was compatible with all
hmm,
different types of operating systems so that it would work on Mac and Linux and Windows. But the people who built ROS just said, we're only going to build it on Linux
right.
and have that be how it is.
Yeah. Yes. It's basically the things you care about most is because people do actually use this in the industry is they really care about stability. So usually you set it up on one computer and then you like never touch it again. Uh,
Yeah.
uh, I
But
wouldn't
I
say
mean, at the
selfish.
same time, um, I guess I would caution you when you install ROS, and this is why virtual machines might be the way to go, because when I installed it on my Linux machine, I like completely broke it and I had to reinstall the operating system. So, I think that's an extreme case and not the norm. But just, be cautious.
Yeah. I mean, it shouldn't really updating Ross. Oh, okay. Oh,
It's
Jack. Hey.
very scary.
Yeah, updating. Yeah, I would never. yeah, I wouldn't even bother updating. Like once you install it, don't mess
Never.
around with it.
Once
um,
it works, and then you just, say
yeah.
thank you and keep going.
Okay, so where did I leave off? And let me just take a look at the question.
Oh, I was gonna open the links, I
Oh
think.
yes, yeah, you want right? We can.
Okay, so I opened the blue screen, and then I have the screen with like the camera, IMU, GPS dots. Should I
Yeah,
open it on
okay.
my phone, I guess?
Um, yeah, I'll explain a bit what this is. So this link is just so that you download the certificate for the WebSocket because I. So the thing about using JavaScript on the web is that nowadays security people care about security, so you can't access the camera and all these sensors unless you are using HTTPS. Um, and I'll honestly I could do like a whole nother lecture on SSL certificates. So I'm just gonna I included a lot of convenience scripts in this repository that I'll briefly explain how to use in a moment. Um, but yeah, and actually that was something I was sort of struggling trying to get SSL working properly. But yeah, so that downloads the certificate. Then you can go to the other link. This one also has its own certificate, but this one specifically like for the ROS instance for the WebSocket. Um,
Also, to the person who said that we scared you away from installing ROS, like we're just saying the exact extreme case. I was like going into my terminal and doing a whole bunch of stuff that you're not really supposed to do, and that's probably why I had to completely reinstall my operating system, and not because like just the steps of installing ROS are inherently dangerous. So don't let us scare you too much.
yeah,
We're
no,
just saying that it
installing
could
it.
be a pain.
Yeah, installing it isn't really dangerous. The only issues is when you install it on a system that it isn't compatible. So okay, maybe I'll do a little bit of an aside. Um, if I go to the installation tutorial again, just wanted to show the versions. So if you try to install, for instance, um, Melodic, which is recommended for 18.04 on an older version of Ubuntu, such as 16.04, or on a newer one even, such as 20.04, you run into problems. You can't really do it. Um, okay, so the question is, why would you bother installing a different version of ROS for than the version of Ubuntu you're on? Well, let's say you're working with multiple robots. Sometimes the packages that people wrote that connect that robot's hardware um, to ROS is written for an older version of ROS. So you sometimes want to use an older version just for ease instead of having to update your code. Um, that's the only real, the simple solution I found is just have a VM for every version, for every robot, basically. Um, Again, today I'm not even really going to explain how to um, like start a robot, connect a robot to ROS. I'll just show how to publish messages that will be interpreted to a robot. I think actually next week there will be a very nice demo by Jack on robot navigation. So definitely stick around for that. Um,
I opened the blue screen, and then I opened the second link you sent. So I
okay,
have the screen that's like camera IMU.
got
Uh,
it. So and did you turn on the camera?
but it's on my laptop. Let's see, camera.
Yeah, it should still use the webcam. Yeah.
Okay, I clicked it.
Okay. Assuming there was no errors, let's find out.
Is it working?
Oh, refresh the page.
Okay, let's do that. Cool. Camera.
Hmm.
Maybe because Zoom is using my camera, so it can't also
Oh, yeah,
use the
yeah,
camera.
yeah. I forgot about that.
Uh,
Um,
I
yeah,
can go to it on my phone, maybe.
I forgot. Yeah, you can't use the camera twice.
Can try. It's not really gonna work. All right. HTTPS this slash. off into dot space colon.
Mm-hmm. Yeah, maybe just. Um,
Ooh, that did not work. Oh, yes. Okay, great. Is it this website? Is it website? Okay. And then the second one closed. Thanks. All right. Into dot
I mean, if
space
it, yeah.
4443 slash sensors. Okay. Ooh, will this work? Maybe.
Yeah, let's find out.
It's acting like it's loading, but I feel like it's pretending that it's loading.
Wait, I mean, just tell me when you clicked it, or you're saying the page isn't even loading.
Yeah,
Okay, well, we're
the
not
page is
gonna
loading.
um,
But you
debug
showed it
that.
working with your phone.
We're not gonna debug that this very instant. In the meantime, I guess let me just uh, show maybe some of the code so to explain what some of it does. So I already showed the launch file. Okay, yeah. I can show this self-signing thing. Basically, in order to generate the certificate, I found this one-liner, which is pretty nice. Um, you just need to specify um, the IP address or domain name. So in order to get this demo working, I luckily enough, I already have a domain name and I had to do some linking, but basically when I sign the certificate, I just do self sign and the domain. So mine is off into that space and it automatically generates the files you need. Um, if you want some more information, I think I include a link that sort of explains a little bit about SSL stuff. Okay, maybe not, but I'll maybe add a link about SSL stuff. Okay. The other thing I want to show was the actual web pages, because that's where the interesting stuff is. So let's go to the sensor web page. How does that work? So first, um, the actual HTML, very simple, just some buttons and an image. Right, so the things you do need, this is, if you load these scripts, this is basically how you, without using like Node or anything annoying like that, if you include these scripts, you basically can use Roslib. Um, they packaged it for you, and you can just source it like this. And then, okay, this one is actually 3JS. I think that helps for doing, because they have 3JS has some good like vector math stuff. And then here's the actual entry point for connecting the sensors. So if we look at ROS Connect, uh, so this is just instead of having image files, I borrowed this from the Roslibjs tutorial online, and for some reason they just have, instead of image files, like the byte information written out as a string. Whatever. It's that little logo of the button I'm using. Not super important. What's interesting is how do you actually start it? So you instantiate Roslibros, which we saw the import for in the HTML file. You can handle connection error and closing. I don't really need to do anything special. It's nice to print out some debug information. Um, in this script, uh, so the one I have on the GitHub is defaulting actually to the first thing, but I needed to add, of course, the domain that I'm using. So feel free to change it. If you keep it this first one, you can run everything locally. But the moment you want to run things externally, you'll need to change the IP address. So then, yeah, it just connects. This is the WebSocket secured, and that's the port number. All this port configuration, like I have it set up in these scripts so that you don't have to worry about the ports. But just so you know, if you want to use custom ports for port forwarding and things like of that nature, you would change, you can change it here, and you have to make sure to sync it up with then the launch file. So where is that? So there's a yeah. So the default one is 990. If you want to change the port when you run, you can do ROS launch. Let me just run the generic. Uh, huh. If you want to change the port, I believe you just do the same way we specified the image. So let's say I want to do 9,000 instead of 90. I'm just looking for confirmation. Right, because I'm already running one, so it complained. Oh, come on. Sometimes takes a while to quit. Okay. Yeah, so that didn't actually change the port. Oh, okay. Actually, I think I know why. Right, I didn't change the port because I didn't expose it. Okay, so I can show you some bit of coding because I'm including Roslibj, which is a package that we installed. In order to pass arguments to it, you need to have the top level argument for port. You can leave it as the default, and then to specify that you want to use your argument for the one that you're calling, you can do it like this.
What exactly is Rossbridge again?
Roslibj, so that's the thing that launches the WebSocket for ROS. So the way that lets it's another middleman to communicate between the web browser uh, and ROS. And ROS is itself a middleman to communicate between well anything and a robot.
So it's one very long daisy chain.
Yeah, it really is. So now after okay, so and I'll push all these changes that I make to make things convenient. So now it should run. Yeah, there we go. You can see the confirmation. It is running with the port that I specified. Excellent. Okay, the actual sensor stuff. So you saw how it connects. Let's take a look at the camera, for instance. Um, so the first thing you need to do is sort of define the topic that you're going to publish to. Um, turns out the web API for cameras sends compressed images. So it's nice to keep. So that's the format that we'll be sending. Um, let's see what else. So there's a function to turn on the camera. This is very hacky. I got this basically from the Roslibjs tutorial. I had to then modify it for updates to browser supports. Like basically, this is all to handle various browsers. Like and honestly, right now it only works. The current files I have only seem to really work for Chrome-based browsers. Uh, yeah, it's just a side effect of web technology constantly changing. So, uh, hopefully this continues working. But the moment something changes, you'll have to update this. Um, yeah, camera off. Right. So then I had a listener for basically capturing. Um, you're right. The video canvas. Um, Here's the main thing. So when you take the picture, you then can just you need to make sure to send it in the right format for the topic. So the image is basically just this format. And for for figuring out the image formats, that's always tricky, and you have to be careful. But if you just look at the documentation for it, so usually the way you want to find it out is you look at the sensor, the topic that you're interested in. So for image, you just Google like ROS image sensor message, and actually we had a specific one, compressed image. So if you're ever curious as to like which thing to search, and it gives you like the format. So it tells you it's you know byte buffer basically. Um, but yeah, fortunately, at least for this part is already done for you here. So then here's listening to the button click. We connect to ROS, turn on the camera, have a timer so that um, it's every few seconds. Video is quite expensive to stream, so it's every 5 seconds we're publishing. Did I skip over the actual publish? Oh, there it is. Okay, yeah. Um, and I guess for people who aren't too familiar with ROS, of course, the vocabulary that ROS likes to use is when you have these topics, you either subscribe to the topic, which means you read information from them, or you publish to the topic, or advertise to the topic, um, which means you're writing data to it. And this is the general layout. So once you have, how to make one sensor, then making another one is easy. So for instance, the GPS one I actually wrote from uh, myself, having to look at the GPS API. So the GPS sensor message includes basically just latitude, longitude. Altitude is apparently optional. Uh, there's a covariance. I could not figure out how to do that from the phone. So you just typically when you don't know how to do things, but you need to have it in the message format, just give it all zeros. And fortunately, it also, if I actually go to sensor messages nav sat fix, uh, I just want to show, is this the one? Yeah, okay, so fortunately for things, sometimes it has attributes, so you see covariance unknown. So because I knew that I didn't know it, I just set that flag to 0. Um, yeah, I mean, again, technically all these sort of nuances of the details of this message really depends on the application that you're going to be using. But because, chances are if you're going to be using GPS, there's probably some package that, uh, helps you use GPS for some useful information. That's the beauty of ROS, is that you can have packages that just use these messages without caring how those messages are generated. So it's a compartmentalization, and that's the general code for creating a sensor. I have a similar thing for the accelerometer. It's just a bit different because, well, different information that we're publishing. There's orientation, the angular velocity, linear acceleration. And we saw that printed earlier. What's the other? Okay, right. So there's just little caveat about SSL again. I have basically the same script here, I believe, um, as well as a little run script in Python to run the Python HTTP server with SSL. So this is, this is like the minimalistic code, and you have to make sure, of course, to yeah. I mean, I don't want to get into SSL, but basically, if you wanted to run this yourself, run self-signed. Either type in the address you want to use, which if you're testing locally, I default it to localhost, or actually I do. You can also do 000. Just make sure that whatever you type here is also what you type into the browser. Am I leaving anything out? Oh yeah. So the thing I do want to show is this is all about sensors. We can also talk about control. So I have another sort of folder here for controlling. So this web page. So this actually I took basically from a tutorial, which I linked in the GitHub as well. The page looks like this. It'll have a joystick. As you can see, I initially used this for a project with Turtlebot, but I'll show you something else. And basically it allows you to either use a joystick or WSAD to control a robot. So how does that work? Let's take a look at, more closely. So similar thing, I have the topic name. Here's the actual topic. So the Turtlebot and the robot I'll be showing in a bit uses something is differential drive, and differential drive in ROS is usually a twist message. Of course, we can take a look at the twist message documentation. If you're pretty simple, it's just two vectors, one for linear and one for angular. And that's basically the controls to feed into the robot, but that means that we actually need to turn the joystick motion into these things. So somebody wrote a very convenient function that does that. And you can tweak parameters here to change speed, basically. Is there anything? Oh yeah, so again, you have to connect to the right IP. I think this is all the same. And then one thing that I added is because of this, we installed the ROS web video server. We can actually stream some of the camera footage to this web page as well. So that for this demo, it's supposed to be teleoperation. So if I'm, for instance, if I attach my phone to the robot with a sensor, with a camera sensor, I can now on my web page control it with the joypad and see the robot's view, and I'll show exactly what that looks like. Okay, so let's just close everything so I can run it again. Okay, so this I'm launching the robot here. Then I will launch the sensor website again. And this is for the WebSocket to connect it together. So I'm two different websites, one for the sensor, one for the control. So now I can show what that looks like. Let me just refresh this. Okay. So I need to refresh this as well. Okay. There we go. Excellent. So then I have a robot here. You guys are seeing, wait, I just realized this is kind of weird because I'm sharing a screen and then sharing a camera. Well, anyways, do you guys see this?
Yeah.
Okay, good. So I'm going to attach this thing to here. And now we have basically a first person view. And if yeah, there we go. I can move so I'm actually moving the robot. You can see my kitchen. Now you can see my computer set up. And so anybody can go to this link right now and actually do this. So I invite people to try it out one at a time, preferably. Or I don't really know what happens when multiple people. Well, I mean, if you think about it, if you both send a message at the same time, it'll basically arbitrarily pick one first. And so you're going to have some deadlock issues, basically. But just, so does anybody want to try it?
Can you send the link in the chat again?
Oh, right. I didn't send. Okay. Now, of course, if you're doing it at home, you probably don't have a robot that's just lying around. Cool. I see some of these moving it back and forth. Yeah, so Arvin mentions you need to do some amount of setup. So in terms of what I provided here is, fortunately, you don't actually need to do much setup on here because the scripts should just work. However, for the actual, there is a lot of setup involved for the robot that you'll be needing to control. So for instance, this one, it's originally just this Lego robot that it's really old at this point too. So it's basically a lot of undocumented stuff. That's the original Lego software is supposed to be like dragging and dropping tiles, but somebody decided to make a ROS package that was very old, and I had to update it. But yeah, if we want to get a view of the actual thing as from third person, so you can see those things. So yeah, I can turn off the camera for now. Right, so I think the important thing to do is if you actually do want to try this at home. Oh, somebody said something. Out of curiosity, how did you first start with ROS? I'm trying to remember when I started. It was actually not that long ago. Well, I guess it was like a year ago, but um, I mean, yeah. So I'm working or I'm studying right now at the robotics lab at Rutgers. So it's basically a necessity. Like when I first started to learn it, I've actually sort of been trying to avoid using it just because it is sort of annoying, and a lot of the work I do is usually more theoretical. But eventually you need to actually do something real. So yeah, you kind of a lot of it's just self-taught. Um, and the documentation, I mean, there's a lot of documentation is just really dense. Is all. It takes time. So hopefully I at least sort of gave you enough knowledge to like start knowing what to poke around in. There's so much more that I didn't cover and so much more that I don't even know, to be honest. Right, but I guess the one thing I want to show before, if you want to do this demo yourself, so whichever robot you do end up setting up, it'll subscribe to some sort of topic. So just if you want to run this demo as simple as possible, just change the topic name here to what the robot needs as input. So for instance, if I change it to this right now, so Turtle One CMD. So ROS has this built-in, really simple robot thing called a turtle sim, which I think I just run like this, and it's still just this little 2D thing, and I believe This should, oops. Oh, no, it's still connected to, oh, I probably have to refresh the page. Okay, I can still hear it controlling the other robot. So there's something I forgot to refresh, but basically, if you wanted to test it out, you can make sure to uncomment, to comment that line, and you can just make sure things are working like this. Um, yeah, I mean, please tell me. I mean, we're basically out of time, but if anybody has questions, like this is a bit disorganized in the end. um, hopefully, you could absorb something.
Someone asked what you work on in the lab.
Oh, somebody asked for that. Yeah. So I do the general sort of area of research is called task and motion planning. I have a few sort of projects that are happening simultaneously. Uh, one is to use a turtlebot, which I wonder if I can get an image. Oh, here, turtlebot. It looks like this, and I'm gonna turn it into. Um, basically going to attach sort of a screen, and then basically some way for people to talk to it, so that if you put it in like a hospital, you can have the patient talk to somebody at home, because right now we're not really allowed to visit people in hospitals. So that's why this teleoperation thing I've been trying to get working. In terms of actual task and motion planning, because that's the more theoretical research, I was working on a project with rearrangement. So if you have a lot of soda cans like on a table, what's the optimal way of sorting them? So that those sort of questions, and then um, but yeah, recently I'm looking into the sort of this interaction with humans as well. So uh, so the thing that I'm interested, yes, okay, cool. Uh,
Okay. So I guess, are there any more questions from anyone else? Something to go over again? Something you didn't understand?
so somebody asked, did I read all the code myself? No, not all of it. I think I tried to cite my sources where I did. So the base, I did rewrite a lot of things though. So this is the original tutorial for publishing video in IMU on ROS.org, and it's basically just one giant file. And they sort of explain it. They actually do explain it, but it doesn't work off the bat. I have to make some modifications, and I want to split it up to organize it better. Like I hate having just one giant file of code. It's terrible. Um, the control tutorial script, I also borrowed a lot from this tutorial. However, I had to modify it, of course, for again, I think it was just one giant file, and I think they use a different robot. So, and again, some things are outdated. So there's just a lot of. It's funny because I originally thought, oh, this would be an easy way to use my phone as a sensor. Turns out I can't even get this working on my old phones, which was the whole purpose of this project, to turn old phones into something useful. Because the browser is outdated. Yeah, so but it's still pretty cool what I can do with like my current phone, to be able to control the robot. So it's nice. um,
Okay.
yeah, I'll update, I guess, the latest changes, and I'll add some more documentation, and then see on how to actually run everything that I showed. Um, but yeah, even in its current state, it should work. Um,
Great. Well, I guess we're almost out of time, but thanks, Dan, for this really cool tutorial.
cool.
And I'll see everyone next week.